Hi data scamps and data champs. Data validation is an important part of ensuring data quality, and Pydantic is the standard tool for this. If you're suffering from bad data, or you're tired of writing clunky custom validation code, then Pydantic is going to make your life easier. In this video, you'll learn how to master the basics of Pydantic, set your own validation rules, and easily handle nested data. Follow along with the code link below, and check out the recommended courses in the description. With that said, let's jump right in.
Hey guys, what's up? My name is Vaibhav Mehra and I'm an AI instructor here at DataCamp. In this tutorial, we'll be covering an increasingly popular library called Pydantic. Now, Pydantic, it's a powerful Python library that makes data validation and parsing super easy using type hints. Now, there's a whole range of applications which you can use Pydantic for. For example, you can build software with it, or you can build your AI agents with it, or anything Python related. The main thing is Pydantic will make your applications much more robust. So if that sounds good to you, I will see you at the code. Again, welcome to the Pydantic tutorial. There are two prerequisites for this course. Number one, Python. You need to know not a lot, but you need to know the basics of Python. And number two is you need to know basic OOP knowledge. Now, I assume you do know these two, and that's why you're here. If you don't, then there are a whole host of resources here on DataCamp which you can use, such as the courses on our website. Apart from that, if you do know them, let's crack on. So, what is Pydantic officially? Pydantic is a data validation and parsing library that enforces type hints at runtime using Python's built-in type annotations. Now, that probably didn't make much sense, but in simpler words, we can get these features. Number one, we can get automatic checking. It checks that the data we receive matches the types and constraints we define in our model. Now, in this case, our model is not like an AI model. It's really a class, and you'll see what I mean in just a second. Number two is conversion. It tries to convert data to the correct data type whenever possible. And number three, it uses structured data handling. So it lets us define complex, nested data structures using these models. Again, not AI models, these are classes. This ensures that all of the data inside is validated and accessible in a structured way without having to write a lot of these if-else conditional statements, which could be, well, quite cumbersome. When writing in Python, we often work with APIs, databases, forms, JSONs, a whole host of external data. Now, this could mean it's quite messy and quite inconsistent or wrongly typed. And that is a huge problem because it can cause a lot of logical errors. And this is where Pydantic comes in. It makes sure that the data we're working with is correct, clean, and well structured. Now, TLDR, we can define the shape of our data once, and Pydantic ensures it stays that way. So, that was the main introduction to what Pydantic is. Now let's actually start coding it. So to start with Pydantic, all you need to do is pip install Pydantic. So I can run this, and you can see that it is installed. And now I can import Pydantic. And this should run flawlessly because it's just a simple pip install. So hopefully it does run flawlessly. Now the key thing to note though is that your Pydantic version, which you can check through this command, must be higher than 2.0. There's a Pydantic 1.0 version as well, but that is slightly different syntax changes. So I'll be using a Pydantic version which is higher than 2.0, in this case 2.1.7. Now, let's crack on with basic models, the first section of this tutorial. So let's create our very first model. So to do that, we need to import this first line. From Pydantic, import base model. Now, base model is arguably the most important thing in Pydantic. This module basically enforces type hints at runtime. Now, to create a model, like I was saying before, we create a class, and this is where you need to know OOP. So we can define a simple class, say for example, a user class like this, class user, and then we pass in base model. Now, in this case, I've defined three fields or three parameters, name, age, and is active. And you can see that I've created type hints for all of them, the string, an integer, and Boolean. Now, there's a lot of type hints which you can do, but these three are the most common, so I've gone for them for this very first example. Now, just like normal OOP, we can create an instance, and in this case, I've called it user1 is equal to Bob, who's 30, and he is active. He's actively a user for whatever company we're making it for. And now if I print user1 and user1.model dump, which you'll see in just a minute, you can see this, that the name is equal to Bob, 30 is active true, exactly what we had written here. And that, the first statement was done by this print statement. The model DUM is in this format where you can see it's in a dictionary format. So we can see the actual name, Bob, age 30, and is active true. So there's different ways to print the same thing. My preference is using model DUM because, well, it's in a dictionary format and I just prefer it. But you can achieve the same print results using either of these commands. Okay, so now let's move to the second example. In this case, I've created a student. Again, it's very similar to the first example where we had created a user, and the only thing which I've changed is the is active from a Boolean type to a string. So the name is string, age is integer, but you can see in this case, I've created a default value. In this case, 18. Now, what are default values? Now, when you instantiate an object in this class, you might not necessarily want to pass an parameter. And this could be for several reasons. For example, if you're building APIs, that API might not have that parameter passed in. So to do that, you can create default values. For example, you could have set this to none. But in this case, I've set it to 18. Now, what does this mean? So if I remove this age and I run this, you can see that name is Jeff, age is 18, and subject is maths. Again, this is quite basic stuff, but we're building it slowly. And you can see that the age has been 18. Why? Because this was the default value. But if I had written age is equal to 16, for example, and run this, you can see that it's overwritten the default value. And you can see that I've written this in the comments as well. By the way, you will be able to see all of this file and run all these examples from the GitHub down in the comment section below. Now let's move on to type validation. And this is where we take it up a notch. And this is the first interesting thing which we're going to see. Pydantic has inbuilt conversion. So if you remember, in the introduction part, I had said Pydantic can convert. It means trying to convert data to the correct data type whenever possible. So we'll see a great example here. Again, we're going to use the user class or the user model which we had defined here. But look at this. Name is equal to Bob, age is equal to 25, is active is equal to true. Do you see what the problem is here? The problem is that age equal to 25, we wanted age to be an integer, but we've passed it accidentally as a string. Now, obviously, this is quite easy to spot, but if you had a lot of parameters and a lot of different objects, this would be, well, very hard to spot. So Pydantic comes in quite well here because it automatically converts it into an integer, because I just ran this and you can see the data type of user2.age is, well, an integer. So that's a great thing. It saved us there. But there is an invalid case though. For example, if I uncomment this and I run this, you can see that we've got a validation error. Why? The thing which I had created, the object, is Charlie, 20, and false. In this case, 20 is not actually the number. It's the actual word of the number, right? And there is no way it can, well, convert that because it doesn't have intelligence like that. So in this case, it was able to convert it because it was quite a simple conversion, just essentially remove the quotation marks and convert it into an integer automatically. But in this case, even if it does remove it, it's still a string or a list of characters, right? So it can't. That's why it gives us a validation error, and it gives us where the validation error has occurred, and input should be a valid integer, unable to pass string as an integer. And you can see what's the value which the error is coming through. That was how to create basic models in Pydantic. Let's move to the next section where we look at fields. Fields let us add metadata, aka data about the data, validation rules, and custom behavior to a model field. This will make more sense as we code it, but if you want some further information, you can go onto this documentation. The documentation is great. If you click this link, this will open up. You can see that it's about fields, and there's a whole host of information about the different subsections. And there's also all of these different stuff here as well. Now, we'll be covering quite a lot of this anyway, but if you want to go deeper and understand all of the different things you can do for fields, I highly recommend this documentation. It's really well written as well. Okay, now going back to the code, we'll create a very basic example. You can see in this case, we've added another module to import, which is field. Now let's create a completely new model, and we'll call it field user. I know it's not very original, but still. And you can see that in this case, I've created one variable, which is name, and it's a string, and this is the field. In this case, I've written the description, so this is the user's full name. Now, this could be especially useful, especially for things like AI agents, where the underlying LLM might want some metadata about what each variable is for. Obviously, you could pass it as a docstring, but it also does help if you provide as much context as possible anyway. So this is one parameter which you can put in field. And if we run this, you can see it's a very simple example, name Weber, which is my name, and we can just print the field user and you get everything, right? This was how you can use a field. Let's go for a slightly more complicated example. If we go here and again, field user default, you can also set default values using field. And in this case, default is John. And if I run this and I don't pass anything, obviously it would be John. But if I had passed in a name is equal to Sam, for example, the name which would have been printed would be Sam. That's all good. But here we go. We have a problem. Pydantic does not validate the default value by default. Now, what does that mean? For example, let's say I've created a model called floor user. Why? Because this user is flawed. In this case, I passed in a parameter age, and the default value is 12. Now, remember before how I had passed in the word 20 and it gave us a validation error. But in this case, it's fine. Why? Under closer inspection, if we print out the user age, it gives us 12. And the type, the string, even though we've specifically asked for an integer. Now, that's a huge problem. You can see that Pydantic only validates user input by default, not the field parameters by default. There are ways we can force validation like this. So let's take a look. For example, to fix this, one of the ways, or a really easy way, is to use this parameter called validate default, which is true. In this case, it forces Pydantic to make sure that this default value is also the correct data type. Now, this is just an extra precaution in case someone else or before you or after you might have accidentally changed the code, and you can see it's a precautionary measure. And now if I run this, you can see that we've got a validation error. Why? Because the default value is 12, and you can see unable to pass string as an integer, which input value was 12. So that's how you can use default values and fix this major problem in Pydantic. We're now going to be moving on to the next section, which is all about aliasing. And I'll see you in the next section. We'll now be moving on to the next section, which is all about aliasing. So let's scroll down and we will talk about what aliasing actually means. So an alias is a different name that a model can use to either accept input, which the technical term is called validation, or give output, which the technical term is called serialization. Now, this is helpful when the external name is not equal to the internal variable name. Now, you might think, well, when will this be helpful? Well, let's explore a real-world example. For example, let's say we're working with a logistics API. And this is the JSON we've received from the API, the package weight in kilograms, the package destination, and package is fragile. But in our Python backend code in Pydantic, we have written it as weight, destination is fragile. Obviously, they are very similar, but they're not exactly the same, and this could potentially throw errors. So this is where aliasing comes in. Hopefully, you've understood that this is quite important. So in this case, going with this example, I created a model called package, and again, it has base model inherited from base model. We've created weight, destination is fragile, which is what we had assumed we're written in the backend code. And you can see now in this case, we've added an alias parameter in the field function. Now, what has that got to do with all of this? Remember how I had said from the logistics API, this is the data we would be getting. So we've got all of this. But how can we match them or create a mapping function or a mapping method which knows that, okay, this package weight in kilograms is to weight, package destination is to destination, and package is fragile is fragile. And that's where this comes in. You can see that this kind of creates a mapping method from package weight, from the alias, from the input parameter of the logistics API to our backend code variable name. And we're about to see how it does that. So package is equal to package and this funny notation. Now, what does this funny notation mean? Now, it might look complicated, but it's really just unpacking the dictionary. So this is the dictionary which we've got, and you can see it takes each key value pair and passes them as the named arguments. In this case, it takes this and passes this and finds out where package weight kilograms is. In this case, is the first parameter and passes the value straight in. So we don't even need to do anything. You can see how many lines of code we've written, barely any. These are all just print statements. So if I run this, it will start to make a bit more sense. You can see that we've got 4.5, Singapore, and true, which are all of these values. And this was the model dump by Alias. So let's talk about it a little bit more. You can see that in this case, I haven't actually passed it in order. You can see that I've done kilogram first, is fragile, and destination. Whereas in the actual class, the variables were weight, destination, and is fragile. So this mapping method, you don't necessarily need to pass the data in the same order as you've created in the class. So that's one thing to note. Now, if I do it package.weight, why .weight and why not package weight kilogram is because the internal variable name is weight, not package weight kilograms. Hopefully things are starting to click now. If I do the model dump by removing this line, for example, you can see that we've got it through the internal variables, the weight, destination, and is fragile. But if I now create this by alias is equal to true, this is how we'd receive the data, and it's by package weight kilogram, package destination, and packages fragile. So hopefully that is making sense now. But don't worry, this is quite confusing at first. So let's do some more examples. Let's move to example 1. In this example, we've gone back to the student, but this time we're using email as the internal variable. And now I've created the two different types of aliases, validation alias and the serialization alias. So what is validation alias again? Well, this is what is accepted as the input, and serialization alias, and this is what's outputted. So the incoming data in this case, let's say from another API, it's student email and hi@gmail.com. Pretty generic email, right? But you can see that because this variable's validation alias, aka what it can accept as input, is student email, it will go and map to this once we actually unravel the dictionary using this command. So if we now run this, we print student.email after instantiating an object from this model class. You can see that student.email is hi@gmail.com. The email itself is hi@gmail.com, because the model.dump we haven't done by alias is equal to true. And if we now print it by alias is equal to true, we get student email, which was this, aka this, and we will get this. There is one mistake which I just made. This student email is slightly different from this student email, and I made that deliberately because I wanted you to see that the validation alias and the serialization alias is slightly different. So when we do by alias is equal to true, we're not actually printing the validation alias, we're printing out the serialization alias here if we've received that. And you can see in this case, we've received the serialization alias. So it's a common mistake. I just made that, as you can see, but hopefully things are starting to click. Now, to make sure that this is starting to click more, let's do one more example, and let's create a book class this time. So in this case, we've created a title and an author. So the validation alias, the serialization alias for both. Book title, then they're quite similar, as you can see. Now, again, we've done a bench data, let's say simple input data we've received, a Pydantic guide, and the author name is DataCamp, okay? Now we unravel the data. Again, book is equal to that. Now I want you to take a second and really try to think what all of these will equal to. Once you've done that, unpause this video and see if you were right. Now if I uncomment this and I press enter and run it, you can see Pydantic guide, DataCamp. The first two should be quite obvious to you because they're, well, just the internal variables. But in this case, title is Pydantic guide, author is DataCamp, but the model dump is book title and author name, aka the serialization alias we had created for all of them, not the validation alias. So just to recap, validation alias, if I go back here, validation alias is the alias which accepts the input, aka from our API. And the serialization alias is what gives the output, what's in our backend code. So hopefully that made sense. You should do some examples yourself, and you will become a master of this quite soon. Now, if we scroll down, there are some numerical limits which you can also set as well. Now, what do I mean by numerical limits? Well, validation doesn't just have to end using just validation alias and serialization alias. In fact, these aliasing is a small part of validation as a whole. For example, in validation, what if you're working with integers? You could want a minimum value, a maximum value. You get the point. There's quite a lot of scope here. So in this case, we can see that I've created a name, a price, and a description. In this case, the name, I've created the minimum length to be 1, aka the length of the actual name, and the maximum length to be 50. The price, I've done GT is equal to 0, where GT stands for greater than. And description, I have said the default is none, so you don't need to pass a description. But if you do pass in a description, the max length has to be 300. If I run this, you can see it runs flawlessly. Why? Because the laptop is within these limits. 999.999 it's greater than 0, and this very cool laptop, we've passed in something and the max length is under 300. But now if I do minus 99.99, you can see we get an error, and we scroll down, you can see that the price is where the error has originated, because input should be greater than 0, because we had set the parameter as greater than or equal to 0. So if I clear this now and run this, well, you will see that it's right. Similarly, if I had passed in the name to be nothing or the price equal to minus 10 again, this will trigger 2 validation errors. And because Pydantic is so advanced, it will tell you each error in a good, well-mannered format, like name and price. So name string should have at least 1 character, and price input should be greater than 0. So it tells you exactly where you went wrong. And that is quite sophisticated, as you can see. Now, there's a whole host of these parameters which you can add into this field category. And if you want to check them out, again, they're all on their documentation. I highly, highly recommend you looking at the documentation as well. Now, I have an exercise for you. So this is the exercise. We need to create a book model again, but this time more advanced. So we need to have a title, which needs to be a string, and it needs to be between 1 to 100 characters long. It has to have a required author, again a string, but there's no limit to this. An optional ISBN, and a price, which has to be a positive float, which has to be under 1,000 units, 1,000 pounds, 1,000 USD, whatever. And it has to be in stock, which is a Boolean value, with the default should be true. So pause the video here, try to create this yourself, and once you're done, unpause it. Okay, so hopefully you've created it and it works. The solution to this was like this. We create a book class or a book model, and we have these parameters. So let's quickly go through them one by one. So we need a required title, where we can see that there's no default is equal to none here, and we have done it in the constraints 1 to 100. The author was required as well, as you can see here. There's no is equal to none, for example. The ISBN is optional, so I pass in the default to be none. The price has to be less than or equal to 1,000 or greater than 0. Well, because it can't be negative, right? So, and it has to be in stock, which is a Boolean value. So true or false, the default being true. And now if I run this command, you can see that there's no errors and it ran completely flawlessly. So that was all good. There's just one small thing I would like to add here, and that is about ISBN. Now, if you don't read books, that's completely fine, but just for your information, ISBN is something called International Standard Book Number, and it's normally exactly 13 digits. The reason I didn't ask you to do it exactly as 13 digits was because to include that in our class, we would need to use something called regex expressions. And now regex expressions, some of you might not know it fully. That's why this wasn't a prerequisite for this tutorial. So in this example, if you wanted the regex expression, it would look something like this. Now it looks complicated and it's beyond the scope of this video, but there are other ways to achieve this, as you can see through this foreshadowing. So let's try to look at that now. So now that brings us to validation once again, and this time we'll be covering a bit more advanced validation. So before we had passed in some parameters and we did some aliasing, but this is really advanced validation. Validation is one of the biggest reasons we use Pydantic in the first place. Now we'll be exploring it in this section. So the most important thing which you need to remember here is @model validator. So this is a decorator and it's used when we want to validate multiple fields together. to perform logic that involves the whole model, and to run code before or after normal field validation. That was a lot, so let's try to break this down. For example, if I create an event model, very simple model, name, start hour, and end hour, with the start hour being integer and end hour being integer. No fancy like 00:00, for example. It's quite simple and we're working in o'clocks. Now if I'd pass in this, event 1 is equal to hackathon, start hour 10, end hour 9. Do you think there's a problem with this? Well, if I run this, it's running flawlessly. But there is a logical error here. How can the start hour be before end hour? So the start hour is at 10 and end hour is at 9. Now before you say what if one is AM and one is PM, we're working in 24-hour clock, okay? So that's a clear logic error, but no matter how sophisticated your type-ins or how sophisticated your internal Pydantic logic is, this is a logic error and this would work flawlessly. But we need to fix this. And that is where model validator comes in. So if I uncomment this line, let's actually break this down. So model validator is a decorator. And in this case, I've passed in the mode to be after. Now we'll be looking at this mode before and after in just 1 second. But if we just skip that for now, you can see that I've created a new function within this class. And this is the check time function. It checks that if self.endHour is less than or equal to self.startHour, well, that's clearly wrong, right? How can the end hour be earlier than the start hour? So that's when it raises this value error. So if I press enter now, well, there you go, we have this error. And you can see that we've got the validation error here, and it says value error, end hour must be greater than start hour, please fix this. And this is exactly what I've written here. End hour must be greater than start hour, please fix this. So this is one really easy way to create more sophisticated models, especially when dealing with logical errors. Now, if we continue proceeding, we'll talk about now the two different modes. Like I had briefly mentioned, there is a before mode and then there's an after mode. So before mode, well, it means before validation, and after mode means after validation. Now, what does that even mean? So I've created this visualization to try to make it a bit more visual and hopefully you understand it better. So let's say we've instantiated the object. Now, before, the data might still be working. Then the validation happens, and then after, the data is cleaned and correct. To go alongside this, I've created this simple code example. So this is a very, very basic model. The user age is equal to an integer. Now user age is equal to 25, but again, we've passed it as a string. This was one of the very first examples we had looked at, but now we're going deep into the Pydantic process or the internal mechanics. What actually happens? Well, once you've actually created the object, which is object instantiation, we move to the next step, the before mode, where data might still be wrong. Now you can see before validation, age is 25. It's still a string here. So at this point, this is 25, aka a string. Then the validation procedures happen, which is the internal mechanics of Pydantic. And then it moves to the after, where data is cleaned and corrected. So you know how we had discovered that Pydantic has self-correction techniques, although basic, but it does have it. All of those happen in this stage, the validation stage, where it's the internal mechanics. So you can see after the validation process, the age is 25. So it's now an integer. So hopefully that made sense. Let's do some practice using coding now. So if I scroll down, this is a before validation example. So the class we've created, the model we've created is called delivery. There's a pickup and there's a drop. So in this case, we're going to be using model validator mode as before. So before we had done after, but now we're doing before. A lot of befores and afters, but you get the idea. And also I've used this class method. Now we'll be talking about class method in just a little bit. You can see that again, I've created a function and it takes in a class variable and data. So the print statement I've done just so we can keep track of the process. But for example, if the drop is before the pickup, that doesn't really make sense again, because how can you drop something before even having picked it up? So that's where this logical statement comes in. If that is the case, well, we can just swap it using this Python function. This is not Pydantic like internal mechanics, it's just simple Python, right? And then we can just return the data. And if I create this order 1 and have pickup as 15 and drop as 13, what do you think the order will be like? it will be like this. So now before validation, we saw that the raw input was this, but after validation, it was 13 and 15. And that's why I also placed this print statement here, because it's keeping track of the flow. So just to make sure that everything is going fine, look at this. This print statement, first of all, the object is instantiated, which was step 1, which is this white box. Then you can see that it went into this model validator process in the mode before. And this print statement happened, as you can see here. And here, it was still pickup was 15 and drop was 13. And this was this orange step. But then the validation process happened, which was this custom logic we had created using this. And if we go to the blue stage, which is after the data was cleaned and everything, and we scroll down, we get to this place, well, they were swapped. And you can see that the print statement, well, it correctly shows the new model, that the pickup was 13 and drop was 15. So, to summarize, model validator can handle multiple fields, but what if we just wanted to focus on one? That is where field validator, another decorator, which is focused on one field. So let's look at that now. It's honestly very, very similar. In this case, we've imported field validator and we've created this. But rather than having a mode, we passed in the price. Why? Because price was one of the variables we had defined, as price is float. And in this case, we have defined it that it must be positive. Now, yes, obviously you could have done this using a field, the internal field mechanics as well, by using greater than or less than operations. But this is just to home in as to what you could do using field validator. So, as a simple example, if the value was less than or equal to 0, we must say that price must be greater than 0 and return the value. So let's try it. If we just do price is equal to 10, no errors. But as soon as I do minus 10, well, we've got that error. And we scroll down, you can see the value error, price must be greater than 0. So hopefully everything has clicked in now. That was really one of the hardest parts of Pydantic. So if you understood that, very well done. And we'll now move to the next section, which is called built-in types. So built-in types. Pydantic ships these helper functions that wrap these common patterns. And this means that we don't need to use regex or extra code. Now this means that it makes development much easier and much more efficient. So let's take a look at this built-in example. From Pydantic, import base model, and then I've imported these three. So the best way to look at these built-in types is if you come from an AI agents background or have ever coded AI agents, you're probably familiar with these tools or inbuilt tools. Think of these in a way as inbuilt tools. They're not exactly tools, but they're still inbuilt and they make coding much more efficient, right? In this case, we have email string, HTTP URL, and positive integer. So if we create a contact model in this case, as you can see, class contact, we can do email as an email string, website as that, and follows as positive integer. Why? Because in every email, every valid email needs to be in a certain format. Now we could define this ourselves using the field validators, but that's just unnecessary, especially if I can just write this, well, using one command. The same goes with website like HTTP and HTTPS, and the positive integer is quite a common problem. So they've just, rather than having to write the if statement, we can just use this. Now, if we create an object and we print this, you can see it runs flawlessly because while this is a proper email, this is a proper website, although it might not exist, but it's still in a proper website format, and the followers is greater than 0. But now let's play with it. If I remove this, for example, and I remove this, and I change this to -10, and I run, whoa, we've got a lot, and we've got 3 validation errors. So the input should be a valid URL because, well, there's no HTTP or HTTPS. The followers must be greater than 0, and the output is truncated. So let me fix those as well. Let's put that, and let's put that. Perfect. And now I run it. We'll only have 1 validation error left, and that was the email. And you can see it's not a valid email because the part after the @ sign is not valid. It should have a period. So if I do this now, .com, everything works once again. So that was how you can use built-in types. There's a whole host of built-in types on their documentation. And again, I highly recommend looking at that if you're interested. Now let's move to nested models. A nested model is one Pydantic model being inside of another model. So this allows us to help organize data cleanly and like JSON objects inside objects. Now, this is getting into the more intermediate/advanced level of Pydantic. So well done for making it this far. Now let's create two models at the same time. So we've created an address model and we've created a user model. In the address model, we have street, we have city, and we have postcode. Each are strings. And the user, we have name, email, and address, where the address is this model. You can see it's not a string anymore, it's this model. So that's what we're doing with nested. Now let's create our data, and let's go this slowly. So we have created a user where the name is Robert, his email is robert@gmail.com, and this address is this street, which I've just completely made it up, by the way. And if I now print this and print user.address.city, what do you think will happen? Well, user is, this, which is Robert's details. The .address, it comes to here, and the .city part is London. So this should print London, which it exactly does. Let's do another example, which is slightly more difficult to really hone this in, where we're again creating two models, lesson and tutorial, but this time we've imported lists. Why? Well, the two models we've created are lesson, where each lesson has a title, a duration minutes, and whether it's free or not, like whether it's paid or not, and a tutorial model, where in each tutorial, there's a name, the instructor's name, and lessons. Now, there can be more than one lesson in every single tutorial. You can think of it as a tutorial or a course, but the point is there's more than one lesson potentially. Now, rather than having to do that, you could have done a lesson 1, lesson 2, lesson 3, but that's just overly complicated and cumbersome. So you can just create a list, for example. Now, let's create a data. So the name is Learn Pydantic, the instructor is me, and the lessons I have created are these 3, for example. Again, completely made up. But the basic models, duration minutes, 10 is free equal to true, and so on. You can see that these lessons come from this lesson model because the title, the duration minutes, as you can see, which is highlighted here, and is free is also highlighted here. And if I run this, you can see that the name, the instructor, and all the lessons come in as lists, each with their separate dictionary. So hopefully that made sense to you as well. Now there is one more step beyond this, and that is recursive model. Now a recursive model is very similar to nested models, but you'll see why they're slightly different. The best example for this is a family tree model. And this is quite probably the most exciting model we'll be building. So in this family tree, we have two parameters. We have two variables, name and children. The name is a string and the children is optional. So why is it optional? Well, optional is a type annotation, which means either a list or none, for example. So the list is a family tree. And notice how there's no second model we've created. It's just referring back to itself. That's where we're doing recursion. Now, when we're making a recursion model, you need to use this familytree.model rebuild. Now, this command tells Pydantic to fully build the model after the whole class has been defined. So if we pass in this data, for example, name, root, and the name of this root, let's say the children were child 1 and child 2. Now, what if child 1 had 2 children? So that would make it grandchild 1 and grandchild 2. But what if child 2 had a child? It could have been grandchild 3. Now, if we run this command and model dumb, you can see that no errors. But this is not visual enough. So I just created this helper function for visualization purposes. And you can see that we have root, we have child 1, grandchild 2, child 2, and grandchild 3. All because we had used one recursive model, no 2 models, but recursive model is technically kind of like a nested model, very similar. With that being said, that brings us to the end of this tutorial. So massive congratulations once again for finishing this tutorial. We've covered quite a lot in this, quite relatively short, but for beginner level tutorial. So we covered basic models, field types, aliasing, validation, built-in types, nested models, recursive models. Now, again, this was a beginner/intermediate level tutorial. The main thing to note is Pydantic is really especially useful when you use it in your own applications, especially nowadays when people are using this to define as state schemas in the AI agents. So if you want to learn how you can use this Pydantic in, for example, Google ADK, you can check out the previous tutorial right here on the DataCamp YouTube channel, where there were sections where I personally had used Pydantic in the Google ADK videos. There are also other places to go. So for example, if you want a written tutorial, you can go onto this URL and there's a whole description of using Pydantic. There are also different courses which you can go to. For example, you can use Fast API for this, model validation, and if you want to brush up your Python skills, you can definitely go to this intermediate Python course as well, hosted on the DataCamp website. With that being said, if you have any comments, feedback, criticism, or any questions, feel free to comment down below. If there's anything else you would like to see on this DataCamp channel, then feel free to comment that as well. And with that being said, thank you so much for watching this tutorial, and I'll be seeing you in another tutorial. Bye for now.